It's a great pleasure to be here, and I'm very honoured to be giving the Allan Sefton lecture for this year, so thank you very much for your hospitality. It's wonderful to be back here again at the University of Wollongong. I'd also like to thank you for the turnout tonight. I live in the tropics, so I appreciate you braving this icy, wintry weather that you have here. So I'm going to talk about coral reefs. That's the title of my talk. So I'd like to just very briefly begin with explaining why coral reefs are important to people, and I don't really want to end the show. Sorry about that. Maybe I'll use this. So this is a map of the world showing in red here the global distribution of coral reefs, and the dotted lines north and south of the equator show the tropical region. And so coral reefs occur right throughout the tropics. They're important for about 80 maritime tropical countries, and you can see that Australia has stewardship of quite a significant amount of the world's coral reefs, about 12%. Australia is very unusual in the coral reef world, in that we are a wealthy, developed nation, and compared to countries like Indonesia or the Philippines, almost nobody lives in Australia. So the human pressures on coral reefs in our part of the world are relatively small. That's not the case in many small, generally poor and developing countries, which tend to have rapidly growing human populations. So coral reefs are important because they provide essential services like fisheries from coral reefs to more than 250 million people, predominantly relatively poor people in developing countries. I think Australia has a big role to play in terms of the science that we undertake, and also expertise in Australia in coral reef management, which arguably is the best in the world. So we punch above our weight, to use a well-hackneyed phrase, in the coral reef realm. Unfortunately, globally, roughly about a third of the world's coral reefs are quite badly degraded, and that has serious consequences. So in developed countries like Australia, the United States, here in Hawaii, or in southern Japan, we tend to think of coral reefs from an aesthetic sort of perspective. We like coral reefs because they're incredibly beautiful, and we worry about preserving biodiversity and managing them for their beauty, and so on. Whereas in the developing world, I think it's fair to say people are more concerned about issues like food security and sustainable development, with the emphasis on development more than likely. And coral reefs to them are important because of the fisheries and the income that they provide through global coral reef tourism. So there are two very different ways of looking at coral reefs, both the sort of Western perspective, but also the developing world perspective. So this picture here shows a sort of idealized food web. So just very briefly, a food web shows top predators at the top, then smaller predators one level down. Then we get to herbivores, animals that eat plants like parrotfish, dugongs or manatees, turtles and sea urchins. And then at the bottom are what are called primary producers. Those are plants mainly that derive their energy from sunlight. And the arrows here show the flow of energy and materials between these different groups of animals and plants. And an ecologist like me can go out and measure the strength of those arrows and get a good idea of how this ecosystem works. What we've seen globally is a shift in the structure and the way that food webs work around the world. So we've gone from a before pristine system with few or no people to a very altered system, where humans now dominate how many ecosystems work, including coral reefs. So people are depicted here as these two blokes in a canoe on the proverbial creek, but this time they actually do have a paddle. Now there are two ways to look at this transition from pristine to human-dominated. If you take a Western perspective, you're more than likely going to say, look at the terrible things that people are doing to coral reefs. we should stop this. But from the developing world perspective, this really shows the importance of coral reefs to people in terms of the delivery of ecosystem goods and services that the ecosystem provides to them. It's very important socially and economically to millions of people around the world. The other point I'd like to make about this picture is it depicts a transition which is happening in many different ecosystems at a global scale, where we've gone from a pristine state to a highly altered state, from A to B, if you like. And if you think of words like conservation or preservation, they're generally about staying at B, or other words like restoration are about going from B back to A. The reality is we've gone from A to B over the last 100 or 200 years or so, and where are we going to be in another 100 years? We're not going to still be at B, and we're certainly not going back to A. Rather, we're going to system C, which will be quite unlike anything we've seen so far. So really, when we think of things like global population growth of people, when we think of global warming, we're already committed to at least a temperature rise of 2 degrees centigrade. There's no way we can stay here. We certainly can't go backwards. We're going to somewhere else. So what will C look like? C, under a business as usual scenario, will probably be a place that nobody in this room or anywhere else would like to go to. So the option really is actively navigating or steering towards a new system C that is of benefit to mankind while still offering some sustainability options for managing ecosystems into the future. So I'll talk about that sort of trajectory in the context later on in the talk of how the Great Barrier Reef is traveling. Before I get to that, this is just a before and after picture which depicts some of the sorts of transitions that have been happening on many coral reefs around the world. So this is a photograph of a coral reef in Jamaica. I did my PhD in Jamaica, so I actually took that photograph in 1978. I should have started off by telling you I started diving at a very, very early age. So I was only 4 or so when I took that photograph. And it shows 2 species of corals. Their common name is the elkhorn coral and the staghorn coral. And they were so prolific in the 1970s, 60s, and 50s when coral reef science began in the Caribbean that the depths where they occurred were called the Acropora palmata zone and the Acropora cervicornis zone. So you could swim for tens of kilometers at, say, 4 or 5 meters depth or at 6 or 7 meters depth along the coastline of most Caribbean islands, and you'd see nothing but these 2 species. Today, those 2 species are endangered. They've become quite rare on most reefs. You still see them on postcards and on tea towels for the tourists and on postage stamps, but you can't find them on the reef anymore in most places. Instead, what you find is a bunch of seaweed. So many reefs, including the reefs that I did my PhD on, have undergone this transition, and there's a whole set of technical terms rather, that describe this transition: phase shifts, regime shifts. They're sometimes referred to as alternate stable states. And that's part of the dynamic that I'm interested in as a scientist. So I want to very briefly just describe that sort of dynamic. So this graph and the next graph, although they look very simple, basically are a blueprint for the research that I've been doing for about the past 25 years. So let me try and explain what this is all about. So this is, on this axis is the condition of the ecosystem, healthy on top and degraded on the bottom. And these are the sort of drivers of change that are affecting the health of the ecosystem. So it's very hard to separate at the impact of overfishing versus nutrient addition or pollution versus climate change. So we can think of this as a set of drivers. Over here, the drivers are at a low level, so our reef is in good condition. Over there, the drivers are at a very high level, so we're dealing with a reef that's thermally stressed, polluted, and overfished. So what we see is that globally, as these drivers have been increasing over the last century or more, for a long time, the corals could absorb all that extra stress. Now that's good news because it means that coral reef systems are relatively robust or resilient. They can absorb a lot of human use and continue to deliver the kinds of benefits that we all appreciate from coral reefs, like fisheries and tourism industries. But after these escalate to a sufficient point, we reach a threshold, and then the system can quite abruptly collapse if the level of these drivers gets to too high a level. So around the world, we're seeing a lot of reefs that are now in this degraded condition because they're heavily impacted by people, but there are still many reefs around the world that are relatively well managed or remote and have low levels of these drivers, and they're still in very good condition. Now, we know a lot about this downward trajectory because of studies like my own, where I initially started working on a reef that was in very good shape, and then over the years it declined. But we know very little about the backward trajectory, about the feasibility of reversing this if we reduce these drivers. And the reason we know very little about that is because it's actually very rare where those drivers are being reduced. So there are only a handful of studies from around the world where overfishing was tackled and reversed. Australia is one example of that, or where pollution levels were reduced. There's an example of that from Hawaii when a sewage plant was built long after it was needed. And of course, there aren't any examples around the world of a reversal of global warming due to carbon emissions. So if we think about the backward trajectory, it looks like this. So what we find is that once a system is degraded, in order to get it to go backwards, you have to reduce all of these drivers way back to here in order to get it to go back. Now, the moral of the story there is prevention is better than cure because of this phenomenon. So many reefs around the world, and also on the Great Barrier Reef, are either still healthy or very degraded, but there's also a growing class of reefs that are moderately impacted by this set of drivers that can flip or alternate between these two different alternatives. And often they flip backwards and forwards because of an external shock, like a cyclone or a bleaching event or a crown of thorns epidemic that can change a healthy reef virtually overnight to a degraded one, or that can potentially change a degraded reef back into a healthy one. So let's look at some numbers that support the notion that reefs can be up here or down there or sometimes intermediate. There's an organization called the Global Coral Reef Monitoring Network, which, as the name suggests, every few years produces a report, which is a compilation on the status of coral reefs in different countries and regions around the world, and they produce reports, the most recent of which was now some time ago in 2008. And that report concluded that in 2008, 19% of the world's coral reefs were so degraded, they'd lost so much of their corals, for instance, that they were very unlikely ever to recover. So those are reefs that are now an airport or a coal terminal, or they're covered in mud or whatever. They're not coming back. They're gone. Another 15% have lost more than half of their coral cover. So there's an ecological record, a monitoring program, where we've seen a trajectory of coral loss with more than 50%. And another 15% of the world's coral reefs fall into that category. An additional 20% have lost between a quarter and half their coral cover. The Great Barrier Reef, by the way, has transitioned from this category into that category in the last 5 years. So the Great Barrier Reef is not doing so well, no better than, say, the reefs of Indonesia or the Philippines in terms of its trajectory of coral cover. Now, if you add those all up and subtract them from 100%, that leaves 46%, which according to this report are at low risk from local threats. So there's a big focus at the moment in coral reef science and to a lesser extent in coral reef management on climate change, on things like global warming, bleaching events, which I'll describe briefly in a moment, and on ocean acidification, which is changes in the pH because there's more CO2 in the atmosphere. But the reality is almost all of this loss so far is due to local threats like pollution runoff from land and overfishing of local fish stocks. So when this figure says low risk from local threats, it's not factoring in the future risks from global warming. And the insidious thing about global warming is even the most remote, best managed and most pristine reef can't be protected from rising temperatures or changes in oceanic pH. So in that sense, these figures are underestimates of the future risk to corals around the world. So that brings me to what are the drivers of change that are important. Well, at a high level, the drivers are how many people there are on the planet. And obviously, that's a growing number. Another driver, independent of the number of people, is how wealthy they are and what they're consuming, what they're eating, and evolving markets. So evolving markets are actually very important. For instance, the market for palm oil or for tropical hardwoods is driving land clearing on coasts adjacent to coral reefs, and that's changing runoff. We're also seeing global markets for coal, oil, and gas, which is changing CO2 concentrations in the atmosphere, which is another threat. We're also seeing global markets for seafood. You can buy a parrotfish in a supermarket in London today that came from a tropical coral reef. And you couldn't do that 25 years ago, and part of the reason it's happening is because of depletion of cold water fish stocks. And so we're now seeing export of coral reef stocks, particularly from countries like Australia, Indonesia, and the Philippines, to China and other parts of Southeast Asia. So those two primary drivers are leading to increases in runoff of sediment and pollution from land. They're also driving fishing pressure, more transport, more mobility of people is leading to introduced or invasive species. And we've also briefly mentioned climate change. Those are sometimes referred to as the threats that are affecting global reefs globally. And the important thing is that all of them are escalating and all of them are increasing in scale. So we no longer worry about just local threats to coral reefs, but we also have to now think about tackling and managing regional and global scale threats, because the scale of them is all increasing, and that's giving rise to some big challenges to how we govern and manage reefs and how institutions are designed to deal with these drivers that operate at different scales from local to global. So that was my introduction. So today I'm going to talk about the Great Barrier Reef and how it's traveling in a global context. You may have read a lot of media coverage of a visit in May this year by a delegation from UNESCO and IUCN. Those are the two global bodies who are responsible for the world's World Heritage areas. And they came to Australia on a site visit because of their concerns over the risks to the World Heritage values of the Great Barrier Reef. And particularly, they were concerned about port development and coastal development more generally along the Queensland coast and the threat that it's posing to the Great Barrier Reef. And towards the end of the talk, I want to talk about whether the current government policies at the Commonwealth and state level are actually working properly to secure a future for the Great Barrier Reef. So let me start with this before and after photograph, this time from Australia. So this is a photograph which I didn't take, from 1882. If you look at this mountain range in the background, that's Australia, Queensland, and that's the same mountain range in the back. So these are the two same places. This shows a reef on the coast of Australia, on the mainland. It's on an island just off the mainland. But it shows a reef which is incredibly vibrant, dominated by corals. These are acropora branching corals. And when I first saw that photograph a couple of years ago, I just about fell off my chair, because there's no reef on the coastal mainland of Australia today that looks like that. That, to me, looks like a reef which today would be 25 or 30 kilometers offshore. But in 1883, that's what coastal reefs looked like. Today, that same place is a mudflat. So it's got some seaweed growing on it, and if you look carefully, you can see some lumps. Those are dead corals. And if you're a paleontologist, you can sample those dead corals and date how old they are. And using that approach, we know that most of these corals died between about 100 and 120 years ago, which more or less coincides with big transformations in how the catchment was used. A lot of land clearing, a lot of livestock, millions of cattle and sheep were moved into coastal Queensland. Sugarcane industry developed more recently. The catchment and how it's used has been transformed over the last 200 years, and that has had a big consequence for coastal reefs. So in terms of the sort of transition that I described earlier, this is a shift from a coral-dominated system to a muddy, seaweed-dominated system, and the chances of that ever being reversed, certainly in our lifetime, are, I would have to say, pretty close to zero. Of course, other parts of the reef that aren't close to land are in much better shape. So if we look at some data on what might be called indicators of these drivers, so these are different metrics. I'll just very briefly describe them. The red dots are the size of the Queensland population, number of people. The green squares are the number of recreational boating licenses. That's the number of tons of coal being exported. This is the amount of fertilizer being used in Queensland. And the last one is the area of the catchment that's being harvested for sugarcane. And I've scaled all of them from 1 to 10. And the point I want to make is that if we look at what's been happening to how we use the catchment of the Great Barrier Reef from 1900 up to today, all of these drivers are escalating. They're becoming more diverse through time. They're all very interactive, but they're a very clear indicator that fishing pressure, runoff, and CO2 emissions in the region adjoining the Great Barrier Reef are all growing very rapidly, and there's not much sign, with the exception of a decline in the last few years in sugarcane harvesting, of any sign of a plateau or of a turn down in any of these drivers. So this is a major challenge. How do we manage the Great Barrier Reef into the future if all of these drivers of change are escalating? And as I indicated a moment ago, many of them are set to grow further. So according to the Queensland Minerals Council, their goal is to triple coal exports between now and 2020. 2020 is only 7 years away. This report was issued in October last year by the Queensland government, and it's predicting a threefold increase in ship traffic out to 2020. And while I've got this graph here, this is a coal terminal on the Queensland coast, and it illustrates some of the challenges of managing ports. There are 11 ports in the catchment of the Great Barrier Reef. Many of them are currently very tiny, but 4 of them are major ports, this being one of them. And you can see this port has a long jetty, and the reason for that is unlike the coastline in this part of the world, the coast here is very, very shallow. So if you take the car ferry from Townsville to Magnetic Island, it's about 8 kilometers distance. The maximum depth you'll travel over is 7 meters deep. Right, so in order to get a ship to where the coal is, or whatever it is you're exporting, sugar, whatever, you've either got to build a long jetty or dredge a trench in order for the ship to make it close to land, or in most cases, you do both. So one of UNESCO's concerns is the amount of dredge spoil which is currently being dumped inside the boundaries of the World Heritage Area. And the amount that is currently on the planning table is huge. Conservatively, if all of the developments that are currently going through the planning stages are given the green light, then about 60 million cubic meters of sediment spoil will be dumped within the boundaries of the Great Barrier Reef Marine Park over the next decade or less. Now, 60 million cubic meters is a hard thing to think about. So think of a trench that's 10 meters deep into the mud by 100 meters wide by 60 kilometers long. That's 60 million cubic meters. If you put it vertical, it would be twice the height of Mount Everest. So another way to think of it is how does it compare to the runoff of sediment from all the rivers that flow into the catchment? So there are lots of rivers, including the Berdigan River, which when it's in flood is the 4th biggest river in the world. And they carry a lot of sediment. The sediment load from those rivers is about 14 million cubic meters, averaged over drought years and flood years. And the estimate of what the sediment load would have been before the catchment was modified is about 3 million cubic meters of sediment. So all of this dredge spoil is roughly 20 times the natural sediment load that the Great Barrier Reef grew up with, that it evolved with, that it could quite easily cope with when we had coastal fringing reefs like the 1883 picture that I showed you. So I think UNESCO's concerns about what 60 million cubic meters of mud, probably polluted mud, will do when it's dumped inside the boundaries are probably very well founded. Okay, so what has been the response of the Great Barrier Reef ecosystem to these rise in drivers, more people, more fishing pressure, more pesticides, and so on? Well, we've seen historically a big decline in megafauna. So there's been, for example, a 98% decline in the number of dugongs on the Great Barrier Reef since about 1960, between Cook down to the southern tip of the Great Barrier Reef. The decline has been much less further north of there. We've lost perhaps 80% of the turtles. There's been big die-offs of seagrass beds and a big loss of corals, which I'll describe in a bit more detail in a moment. So we've got very distorted food webs, like the transition that I showed you earlier from a food web with few or no people to a human-dominated food web. We've also seen increased bleaching of corals during 2 relatively recent El Nino events that are attributable to global warming. We see more coral disease, and increasingly we're seeing outbreaks of starfish, crown-of-thorns starfish. In general, what we're seeing is a loss of resilience to the reef to natural cyclones. So cyclones and floods are a natural part of the dynamic of coral reefs. Coral reefs have evolved to deal with cyclones. They bounce back from them if they're a healthy ecosystem. But what we're seeing more and more around the world and in Australia is that that resilience is being eroded. So a reef which is muddy or overfished often loses its capacity to bounce back after a big storm or a cyclone has occurred. So moving on quickly to what's been happening with coral cover. There are actually 4 studies published, the first one in Nature, that looked at trajectories of coral cover on the Great Barrier Reef over these different periods basically from the 60s up to pretty much the present day. And they all say the same thing. More than half of the coral cover on the Great Barrier Reef has been lost over the last 50 years. Now that's important because corals are the backbone of a coral reef. If you don't have corals, you don't have a coral reef. It's like a forest without the trees or a kelp bed without the kelp. Many, many species depend on the three-dimensional habitat that the corals provide. If the corals die, the ecosystem changes dramatically. And what we've seen, here's just an example, is a dramatic loss of corals. So the axes here these are different categories of coral cover from data before 1980 to more recent information after the year 2000. So this is a compilation of information from all these studies. The Barrier Reef was actually very well studied in the 1960s and 70s. A big focus was on crown of thorn starfish outbreaks beginning in about 1962-63 and the recovery of corals that occurred after that. So there's actually about 120 estimates of coral cover from this early period. And so this is the percent of reefs that fall into those two different categories. And you can see the tallest blue bar there representing about 40% of reefs. Those reefs had between 40 and 50% coral cover. And this is the distribution of coral cover much more recently. And here you can see that most reefs fall into this bottom category. That's reefs with 10% or less coral cover. So that's a huge transformation, a huge loss. That loss has been far greater on coastal reefs, like the before and after picture that I showed you. There's been almost no change on reefs that are in the most remote, far northern part of the Great Barrier Reef, or in the reefs that are furthest from shore on the outer part of the continental shelf. A big issue for coral reefs globally is coral bleaching. Coral bleaching is when the corals lose their color, they become thermally stressed, they go white, hence the term bleaching, and it's driven by global warming. So we're seeing these very large-scale bleaching events. Corals that bleach are stressed, and they have very high rates of mortality afterwards. They can recover, but often they don't if the bleaching is prolonged. We've seen two big bleaching events along the length and breadth of the Great Barrier Reef in 1998 and again in 2002. Those were two strong El Nino years. And we're bound to see more of those into the future. Now, if I want to dramatize the impacts of bleaching, I'll show a picture like that, because this shows a staghorn coral, and those species are particularly susceptible to thermal stress. So that's one big thicket of one genetic individual of this particular species. You could call that George. And that big colony has bleached, but probably a more typical picture looks like that. So that's George, and that's Fred, and that's Mary, right? So these are different colonies. And that looks more like a checkerboard than the snow white seascape that I showed you before. So an important issue for loss of coral cover is that most of the agencies of that loss are very, very selective. So storms are selective, bleaching is selective, sediment is selective. And so a part of this barrier reef story with this loss of coral cover is that the mix of species is changing. And that's shown here. So this is the percent of different species. I've spared you the Latin names, so that's species A, B, C, D, and so on, that bleached in this particular bleaching event. So these first two are relatively susceptible, and species I and J out there didn't bleach at all. So what's happening with these recurrent bleaching events and all the other things that are killing corals is that we're losing susceptible species, whereas the more robust ones are hanging on. In fact, some of them are actually increasing in abundance. So globally, the species mix of corals is shifting in a way that's changing the ecology and how these reefs work quite profoundly. For example, these two species here, this is a branching coral and that's a table coral. So they're very three-dimensional. So what's tending to happen is that the more robust corals are sheet-like or small mound corals. So the three-dimensionality of the reef is shifting from highly three-dimensional to more bunkered down. And that's changing how many nooks and crannies there are in a reef. It's altering the habitat and its capacity to shelter all the species that depend on corals for their livelihood. Another issue is crown of thorns. Now, I think it's fair to say that the Australian government has been trying to blame the decline of the Great Barrier Reef on two things. One is monster starfish, and the other is acts of God, like floods and cyclones. And I think that misses the point entirely, because cyclones and floods are part of the natural dynamic of the reef, which the reef has evolved to cope with. So that's not the problem. The problem is now they're not recovering as well as they used to. Similarly with crown of thorns, we have to understand what are the causes of these outbreaks, that they're not aliens from outer space. So to me, although they might look like it, to me, crown of thorns outbreaks are a symptom of a sick ecosystem. They're not the cause of a sick ecosystem. So the most plausible reason for why these outbreaks are occurring, and we've now had 4 over the last 50 years or so along the Great Barrier Reef, is that it's driven by runoff of nutrients from land. So if you experimentally rear the larvae of this starfish in an aquarium and feed them with more nutrients, the larvae develop much faster, and instead of, say, 100 settling after 4 weeks, you'll get 10 million settling after 3 weeks. Those are the sorts of numbers. So the most plausible reason, and there's a lot of work being done on this, for why these outbreaks are occurring is that the larvae are being nourished by runoff of nutrients from land, which is causing these population outbreaks to occur. So I've painted you a picture in the limited time that's available of how the Great Barrier Reef is traveling, and it's a mixed report. Some parts, the more remote parts, are doing okay, they're fine, and they're clearly supporting a vibrant tourism industry. So I don't want to overstate the degradation that's occurring, but across the whole Barrier Reef, it's a fact that half the coral has gone in the last 40 years. It's a fact that crown of thorns starfish have now become routine and they're very destructive, and it's a fact that coral bleaching has occurred twice in the last 16 years or so. So I want to move on now just to the last part of the talk and talk about some of the ways that management agencies are dealing with these escalating drivers and shifts in the ecosystem. So I think one of the triumphs of management of the Great Barrier Reef in recent years was the recent rezoning of the reef that occurred in 2004. So these are 2 maps, if you like, a before and after map of the Great Barrier Reef. Until 2004, 5% of the marine park, which is this big blue area, was designated as so-called green zones. Green zones are no fishing zones or fish reserves. You're not allowed fish in them. 5% obviously isn't a very big proportion of the marine park, and you'll notice that most of the green zone was in the very far north, in the most remote place. The reason for that is it was the place where fewer people would protest about it. So. And arguably the place where it was needed the least, right? And that's fairly typical of marine and terrestrial parks globally. We tend to put them in fairly ridiculous places for political and social reasons, rather than because that's the place where they'll do the most good. There are lots of different types of zones apart from green zones, which I'll explain in just a moment. But the big transformation that occurred when this legislation went into effect in the middle of 2004 was a change from 5% to 33%. And you can see that the 33% green zones is now much more evenly spread throughout the Great Barrier Reef. So a lot of thought went into where these green zones should be placed. And for people like David Eyre in the audience who works on gene flow and where larvae are transported to, the idea was to build up a network of green zones that could communicate with each other, so that if one green zone got into trouble, if you like, it could be rescued by replenishment from other zones that were within the transport distance of different types of larvae. So let me just briefly describe the zones. There are actually 7 zones, green being one of them. So if you go from left to right, we're basically going along a set of things you can do and can't do inside those different zones. So these are some activities: aquaculture, crabbing, collecting, fishing, tourism, trawling, and so on. The most stringent zone is so-called pink zones. Somebody said to me, lavender is the new pink. Sorry, the colors don't quite work. In a pink zone, you can't go in. The only person who can go in is a researcher who has a very good reason. Pink zones are mostly rookeries for turtles or for seabirds. So in order to absolutely minimize human impacts on those very sensitive systems, and we're talking here about a tiny, less than 1% of the marine park, you just can't go there. The next most stringent are green zones, where you're not allowed fish. You can, however, go into a green zone and go diving and boating and take pictures. That's okay. Where's that? Anyway, the X means you can't do it, the tick means you can do it. The point I want to make is that this is a continuum of management stringency. So by the time you get down to the blue zones, there's lots and lots of ticks, and you can do pretty much whatever you want to. So those zones represent gradients of the intensity of management, if you like. So what I'd like to do now is show you how effective these zones are. And I know here in New South Wales, no-take marine zones, the equivalent of green zones, are quite politicized and controversial. And I've heard many politicians say that the evidence for green zones is equivocal, which of course is total bull. And I'll show you that in a moment. So here what I've got is some plots of the abundance of sharks, 2 species of sharks. These are 2 different independent studies that basically used the zoning of the Great Barrier Reef as a sort of experimental design. So they went to pink, green, yellow, and blue zones and looked at how the zoning impacted on the number of sharks that you can find under those different management regimes. So just to reiterate, pink is you can't go there. Green, you can go inside, but you can't fish. Yellow means you can fish if you're a recreational fisher, but you can't fish there if you're a commercial fisher. And blue, anyone can fish. So if we look for these 2 studies, this one looked at 4 zones, that one looked at 3 zones. You can see this sort of steps of stairs effect of the zoning on the shark population. So where people can't go, there's lots of sharks. Where they can go and do whatever they like, there's very, very few sharks. And if you think of the proportions of the reef that used to be in green zones that are compared to now, and compare that to blue zones, until 2004, you could fish in 95% of the Great Barrier Reef, and so it would have had densities equivalent to down here. So we've seen a big resurgence of fish populations in these new green zones. And these are some of the older zones, but it's very clear from this data that these zones work in terms of protecting and rebuilding fish populations. I'll show you another example in a moment. An interesting point here is that you're not allowed fish in green zones. Equally, you're not allowed fish in the pink zones because you can't even go in there. So in theory, there should be the same number of fish in a green as in a pink zone. That's not the case. Why not? It's because of poaching. So if you're caught in a pink zone by a plane flying overhead, you're nailed. right? That you'll be in court the next day. But if you're in a green zone, you hear the plane coming, and you haven't got a rod that's visible, then you're entitled to be in the green zone. But there is, as evidenced here, a significant amount of poaching going on in the green zones, although they are still better in terms of protecting these shark populations than where you can freely fish. Most of the recreational fishing and a big part of the commercial fishing on the Barrier Reef is for this species. This is the coral trout. And here's just a typical result from a green zone compared to a blue zone, about a 5-fold disparity. So this gives you some indication of the extent to which fish stocks on the Great Barrier Reef, which are relatively lightly fished compared to somewhere like Indonesia or the Philippines, have nonetheless been altered by human activity. And in terms of the coral trout, the commercial fishery and the recreational fishing catch is about the same. It's actually slightly higher for the recreational fishers. Going back to these zones, one thing which has become very clear over the last few years is that this zoning is not sufficient for managing the Great Barrier Reef into the future. The Great Barrier Reef Marine Park was created in 1975. It went into operation in 1976. That's a long time ago. At that time, it was the world's largest marine park by a huge margin. And so it was incredibly visionary for that time. And this management zoning approach evolved over time. But the whole idea all that time ago was to design a marine park, create a new agency, the Great Barrier Reef Marine Park Authority, where the buck stopped. So that agency was designed from scratch. It was put in charge of the entire Great Barrier Reef, 2,000 kilometers of coastline, one agency. So it was really a visionary thing to do. In effect, what they were doing from a governance perspective was designing an institution that was scaled appropriately to deal with all of the local threats that were affecting that reef. Unfortunately, what's happened over time, going back to my point earlier about drivers escalating and becoming bigger and bigger in scale, is that the agency has shrunk relative to the scale of the problem, the scale of the drivers, right? So now we've got big issues with runoff from land, and the Great Barrier Reef Marine Park Authority has no authority on what happens on mainland Queensland, and of course they've no authority to deal with global warming or ocean acidification or Australia's greenhouse gas emissions policy. So we look at these zones and what you can and can't do inside them. There isn't an impact called coal ports or runoff from land or sugarcane fertilizer use or CO2 emissions. So that's a big problem. What was a custom designed state-of-the-art system of governance is now beginning to fail because the drivers have shifted in scale. So the big challenge moving forward, I think, is to realign the scale of management with the scale of those drivers. And that's going to require a lot more Commonwealth state cooperation so that activities on land, particularly in the coastal zone, for dealing with UNESCO and other concerns, can be taken on board as part of the management of the Great Barrier Reef. So if I could summarize all of that up, the three big drivers of change that are affecting the Great Barrier Reef and indeed reefs globally are climate change, runoff and overfishing, and those three all have to be addressed. At the moment in Australia, we're dealing basically with one of them. So I would give an A+ to Australian agencies for managing coral reef fisheries. The green zones and the rezoning have been highly effective. When it comes to runoff, you'd have to give them an E, which is a fail. And in terms of climate change, I think it's a no grade because they haven't actually shown up for the exam. And all of these are highly interactive because a reef that's overfished and polluted is much less capable of coping with climate change. So we can't just solve one problem and leave the other two unsolved. The other issue in terms of reversibility of these regime shifts, once a reef becomes degraded, it almost always stays that way. So prevention is better than cure. And given that all of these drivers are escalating, that means we're running out of time. But I don't want you to go away from this talk and be suicidal. I'm actually cautiously optimistic that we can manage the Great Barrier Reef. As I said early on, the challenge is not to stay where we are at System B, having gone from A. It's to actively steer towards a new System C that is both sustainable ecologically, but also has societal and economic benefits. And finally, we're really at a crossroads in terms of how we manage things like dumping of dredge spoil, and we've got some important decisions to make over the next few years, and whether we make the right ones or not will have huge repercussions for centuries to come. Thank you very much.
So Terry, how do we move from an E for runoff to an A?
Well, that's a good question. To my mind, the loss of half the coral cover on the Great Barrier Reef, the loss of most of the megafauna, is a national disgrace. It's an ecological crisis that's every bit as big as what's been happening to the Murray-Darling Basin. And the government has allocated, I think it's $10 billion to fix the Murray-Darling. The government's response to the UNESCO's concerns and the most recent report on the loss of coral cover has been to allocate $800,000 for eradication of crown of thorn starfish, which is basically akin to chasing a locust plague with a butterfly net. And they're not, to my mind, crown of thorn starfish outbreaks are a symptom of a degraded ecosystem. They're not the cause. So they need to deal with runoff. And I think what we need is something like a Royal Commission that would trigger another $10 billion to redesign how we use the Great Barrier Reef catchment. And I'm not an expert in planning catchment use, but I think we need to put all the cards on the table. I think we need to rethink it. So is sugarcane the ideal crop to grow beside the Great Barrier Reef? Does the world need more sugar? Or in the context of carbon credits and shifting how the world uses energy, should we be investing in carbon sequestration, carbon offsets in the catchment as a way of reducing runoff and restoring some of the trees that have been cleared? Should we be investing billions and billions of dollars in port development and new coal mines, when in all likelihood that industry won't be with us in 30 years' time? Because we have 200 years reserves of coal in the ground in Australia. I think the likelihood of all of that being dug up and burned at this point is pretty small. And I think we're starting to see big banks having second thoughts about investing in that kind of infrastructure. And I noticed reading the newspaper the other day that BHP is selling its Queensland coal mines because they've been losing money. So I think the economics of how we use the catchment, how we burn coal and make energy are shifting very, very rapidly. But I think we need to plan that. There are 11 ports along the coast of Queensland. There is no plan, no rational plan for how those ports would be developed as a system of ports. There's individual ports doing their own thing. That's part of UNESCO's concern. So we haven't managed the Great Barrier Reef system and its catchment as a whole. It's very sectoral. So we manage the Great Barrier Reef, we manage agriculture, we manage energy, we manage ports. What we need is an integrated system that actually looks at the connections between all of those pieces. And it won't be cheap, and it certainly won't be solved with $800,000 for starfish.
Just a quick follow-up to that, Terry. Do you know if there's technology? I mean, I don't think you're going to change the land use in the catchment. I mean, unless you spend lots and lots of money, and even if you're prepared to spend lots of money, as they have in the Murray Dam, there's still a lot of resistance because you're going to make communities uneconomic and etc. So, I mean, I just wonder if the technology, you know, and I'm probably asking an unfair question, but is the technology there to intercept the sediment? I mean, could you say to farmers, well, you've got to do something on the land which will stop the sediment running, or is that just not on?
No, there have been improvements to that, and there is a lot you can do. So there's something called Reef Rescue, which is a $300 million 4-year program, which has just finished, and it hasn't yet been renewed, as far as I'm aware. This is all happening at the time when, you know, Wayne Swan wants to balance the budget. So politically, the timing for doing something in response to the confirmation that half the coral cover has gone is bad. But I don't see either side of politics making a response. So the federal opposition's response to new evidence that Crown of Thorns were a big issue was to say that the Labour government had wrongly blamed recreational fishers for the decline of the Great Barrier Reef, therefore the new green zone should be ran back. Right? The logic of that escapes me. You know, if the Great Barrier Reef is declining, why would you roll back the most successful management intervention of the last decade? So I'm afraid I'm not optimistic that the politicians are going to fix this for us. But I don't know how politically realistic that the catchment will be changed or not. Perhaps it won't happen, but I think we need to deal with this issue. There are things you can do in terms of managing runoff by building buffer zones around waterways, restoring some of the waterways that have been drained, dealing with overstocking of grazing leading to soil erosion, planting trees in strategic locations, and so on, dealing with sewage. There have been improvements, for instance, in how aquaculture effluent is dealt with. So there are new management for aquaculture, even though it's not an industry that's operating within the marine park, because it's impacting on the marine park under current legislation that is being regulated. But as I said, the Great Barrier Reef Marine Park Authority only has provenance from low tide seaward, but many of the issues are in the atmosphere and on land, and so we need to link what they're doing on the ocean with the drivers that are much bigger than scale.
What we might do is we might stop there from Allan. Terry's going to be staying around afterwards. I'm sure we have. Continue to be informed.
Thanks very much.